Okay. Okay. So my screen is visible to you, right?
Yes, ma'am.
Okay. Yeah. So just a second. Okay. So day before yesterday, you have seen this example, a simple example where this uh, where it was discussed that how a particular data is basically being processed in MapReduce, right? So this is, let's say this is the same sample file you have, okay, and it is being split into three subparts line by line, okay, and since MapReduce basically takes data in the form of a key value pair, okay, be it your input, be it your output, MapReduce basically works in the form of a key value pair. Okay, so here, so did you had a discussion over how the files will be split? Can anyone tell me? Hmm? एनी आइडिया कि की वैल्यू पेयर्स के फॉर्म में ये डेटा किस तरह से डिवाइड होगा, स्प्लिट होगा बेसिकली?
row wise.
Yes, row wise, but in since I'm saying that it is in the form of key value pair, तो वो फाइल को किस तरह से डिवाइड करेगा? What it will do, it will take the first row, okay, and here this entire row will be the value, okay, and the starting point of this first row, okay, that is the first offset value of the first alphabet will be the key. Okay, so let's say ये टेक्स्ट फाइल है, तो अगर देखो यहाँ पे ऑफसेट वैल्यू विल स्टार्ट फ्रॉम ज़ीरो, सो बस विल हैव द इंडेक्स ज़ीरो, सो यहाँ से काउंट करेंगे हम ज़ीरो वन टू थ्री, इट विल टेक द स्पेसेस एज वेल, 4 5 6 7 8 9 10 11 12, so last is your 12, okay, so offset value will start from 0 to 12, तो यहाँ पे जो इनिशियल ऑफसेट वैल्यू है दैट विल बी द की. ओके, सो द फर्स्ट रो के लिए हमारा की वैल्यू पेयर क्या होगा? फॉर द फर्स्ट रो की विल बी 0 and value will be the entire line. For the second row, the offset value will start from, since last one is the 12th, then here यहाँ पे offset value start will be from 13th, okay, so t will start from 13, 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27, last is 27, okay, so offset value will start from 13 till entire row, then third will start from
18.
28, यहाँ पे 27 is, this is 27, okay, so from 28 to entire row. So यहाँ पे जो डिवीजन हुआ है, यानी कि आपके मैप फेज के लिए जो इनपुट जाएगा वो इस फॉर्मेट में जाएगा, ओके. नाउ द rows are divided into key and value pair, okay. Now this input will go to your mapping phase, and what mapper will do according to your yes according to the data you are receiving, what mapper will do, since what we are doing here is basically we're counting the number of transport vehicles, okay, occurrence of transport vehicles, okay. So what it will do, it will do the tokenization. It will break this value into a value we are passing it. It will break that, okay, into the tokens. So tokenization, what we are doing, that we are defining that you have to take the tokens between the spaces, okay. So let's say it will start from this, and till it gets a space it will consider a one word, okay. So likewise it will do the tokenization of word, and once it is doing the tokenization, what it is doing, वो हर token के respect में it will assign an occurrence as one. By default it will, not by default, by explicitly we are saying that you assigned occurrence as one, okay. In the third one this should be like this, okay. So this image is basically incorrect, okay. So since bus is coming twice, see यहाँ पे उसने, it will not say कि okay bus is coming twice तो two लिखेगा, no, it will again say one only, because we are explicitly, what we'll do, we'll code this explicitly that for each occurrence, for each token, you assign the occurrence to be one, okay. So this is what your map phase will do, okay. Now understand this, that since this is one file, okay, this file is divided into three parts. The code will be written for only for single time only, okay. It's not like कि आप you'll write a separate code for this, separate code for this, separate code for this, no. We'll write a single map logic, okay. But what Hadoop does is, in the backend, the number of splits it is creating, वो उन्हीं basis पे उतने ही number of map functions को create करता है, ठीक है. उतने ही मैप फंक्शंस विल बी वर्किंग. लेट्स से अगर यहाँ पे 4 स्प्लिट्स होते या 5 स्प्लिट्स होते, तो अकॉर्डिंगली 5 मैप फंक्शंस would be working, okay. You can say it कि आप जो map logic you're writing, that is basically a duplication what you're doing, okay. The duplication has happened and then the processing has happened. इसीलिए that is why we are saying that it is doing the parallel processing of the data, okay. Your data is being divided and processed parallelly in order to give you a faster performance, okay. Then your map phase is done. Then comes your intermediate splitting. What is intermediate splitting, or you can say it as shuffling and sorting phase? Here what happens is, whatever output your map function has generated, okay, at this phase what happens is the shuffling of all the key value pairs. Now see, here the map function will also, see, mapper will take input as key value pair, output will also be generated into a key value pair. See, okay, so keep in mind that whatever kind of processing you are doing, not just for this type of data, any kind of data, okay, whether you, let's say आप weather data पे भी अगर आप work कर रहे हो, for any kind of data, any kind of processing, the data will be the data will be accepted in the form of key value pair only for MapReduce, okay. It, the basis of MapReduce is only key value pair, okay. Now it is up to you that how you decide your keys and how you decide the values, okay. Basically key should be a unique thing, okay. Here, since we are doing the count of the number of vehicles, okay, number of different distinct vehicles in this file, okay. So here the distinct this the distinct word where we are finding that distinct number of distinct vehicles, okay, that is the key for you, okay. And the values will be their occurrence, okay. Likewise if there is another another data. Let's say you are working with weather kind of data. There the problem will define what kind of processing you are doing, and with weather data you will what kind of interpretations you want to create. Okay, whether you want to judge that what was the hot day and the cold days, or whether you want to figure out that how much rain has uh, how much rain was has fallen in this year, or in the month of this uh, or for a particular set of months, the rainy season you call it. Okay, so whatever kind of processing you want to create, based on that your key value pair will be created. Okay, and the decision will be yours. Okay, what key you should want to have and what kind of value you want to create out of it. Okay, so here the key value will be now changed. देखो input ये गया था. ओके, आउटपुट क्या जाएगा, उसने टोकन्स क्रिएट किए, टोकन्स के रिस्पेक्ट में उसने उनका अकरेंस जनरेट कर दिया. नाउ दिस इज अगेन अ की वैल्यू पेयर. नाउ दिस की वैल्यू पेयर्स will be shuffled. Okay, and what it will do is that it will keep all the uh, identical keys. Okay, it will keep the identical keys together. Okay, and do the shuffling. So all the similar keys will be placed and sorted accordingly. Okay, now again there is a rectification here. यहाँ पे ये 1 होगा, and again this will be bus and 1. Okay, so this is how your shuffling has happened. Okay, now, once this shuffling has happened, now what we'll do is this input will go to your reducer. Okay, now what this reducer will do, it will see that how many similar keys I'm having, and with those similar keys what is the um, occurrence. Okay, so what it will do, it will keep bus as a key. Okay, and a bag of occurrence of bus will be generated. Okay, likewise for car, likewise for train, likewise for plane. Okay, and reducer will act upon this, and वो बस के रिस्पेक्ट में ये जो occurrences है इनका एग्रीगेशन परफॉर्म करेगा, and it will create give you the aggregated result. Now each reducer has generated its result. Now this result is final, will be combined, and your final output will be generated. Okay, so this is how your map reduce basically works. Okay, so if you see in the backend how things basically work, जब हम बात कर रहे हैं, then we are talking about that how the shuffling and sorting is happening, how the splits are being created, what is going in the backend, that is there. So you have your input stored in your HDFS. Okay, the your data is being fetched from HDFS and passed to an input format. Now this input format is basically responsible for doing your for doing your initial split. Okay, जब हम initial split की जो बात कर रहे थे, यहाँ पे ये वाली चीज आपका इनपुट फॉर्मेट कर रहा है. ठीक है, देन योर इनिशियल स्प्लिट input split is being created. Okay, now what this record reader does is record reader identifies how the key value pair will be generated out of the splits. Okay, now here the record reader will produce the input key and the value pair and will pass it to your mapper. Okay, now mapper will do the processing, tokenization, or whatever kind of logic you have applied to your map, uh, whatever kind of logic you have applied to your map function. So accordingly, it will generate the key value pair, and that we call it as intermediate key value pairs, because they are not the final values. Okay, they are just intermediate pairs. Then comes your combiner, and partitioner. So these both are basically involved in, you know, जो हम शफलिंग और सॉर्टिंग की बात कर रहे थे, उससे पहले शफलिंग एंड सॉर्टिंग से पहले ये जज करना इम्पोर्टेंट है कि हाउ योर डेटा इज गोइंग टू बी फर्दर एनालाइज्ड. ओके, सो in the backend, combiner and partitioner actually works together to figure out this thing. Okay, कि आपके जो की वैल्यू पेयर्स जनरेट हुए हैं उन्हें किस तरह से, किस फॉर्मेट में, बिकॉज सी हियर, though we are seeing a small example here, but your actual file will not be that small. Okay, it will be a huge file. Okay, GB या terabytes में आपका फाइल होगा. Okay, तो अगर इतना बड़ा डेटा है तो you need a proper mechanism to basically do the shuffling and sorting and preparing the data actual to do the shuffling and sorting. Okay, so that is being done by the combiners and partitioners. Then comes your shuffling and sorting. So shuffling and sorting will basically arrange your key value pairs. Okay, they will segregate them and they will arrange a key value pair. Also, the shuffling and sorting will basically convert your data into this format: bus and the bag of words. Okay, sorry, one. कि ये जो बैग ऑफ अकरेंस है, ये इस फॉर्मेट में आपका डेटा को कन्वर्ट करेगा, शफलिंग एंड सॉर्टिंग. वंस योर डेटा इज बीइंग कन्वर्टेड हियर, दिस इज बीइंग पास टू योर रिड्यूसर. Okay, now reducer will create a key value pair. Again the key value pair will be generated. Now this key value pair will be the final key value pair, or this will be the aggregated one. Okay, then all the outputs from the reducers are passed to your output format, and they basically combine all the results and produce the final output. Now this final output is then stored in your HDFS. Okay, so let me tell you that for the MapReduce, the the thing is that for each step, okay, for each step there is a read and write operation happening. Okay, so what will happen, your input split has taken place, record reader, then mapper function will work, mapper function will generate a key value pair. Okay, then this key value pair will be again stored in your storage space, then it will read again by the combiners and partitioner and then pass to your reducer. Okay, so there are number of read-write operation basically taking place when a MapReduce processing is happening. Okay, that is why the output will be automatically stored in your storage space. It, you will not see that in your terminal. Okay, आप अपने terminal पे उसे directly result नहीं देखोगे. You will, it will be stored in a file and then you can see the content of your output by accessing that file. Okay, so this is how your MapReduce basically works. Okay, now the problem, so let's understand the architecture of MapReduce. Okay, so this architecture which we are talking here is basically the scenario where Hadoop 1.0 was there. Okay, so I told you that there were things which were differ from Hadoop 1, Hadoop version 1 and Hadoop version 2. Okay, so in Hadoop version 1, the scenario was like, since I told you that in version 1, there the resource management was taken care by the MapReduce only. Okay, and for version 2, which thing what edition which we did in the version 2? Can anyone tell me? Yes, anyone? Do you remember I told you that version 2 has another resource manager, and what we call
Is
it?
it yarn?
Yes, it is Yarn. Okay, so we need to understand that when already we were doing resource management in version 1.0 through MapReduce, what were the reasons that we had to introduce Yarn in version 2? Okay, we should have an understanding with that. Okay, so let's discuss about the same. So here the scenario is that you have your input file. Okay, the splits are being created. Each split is going to an individual map function. Okay, just a second, please. Uh, Everyone, please make sure you join the session at 3. Okay, because it is difficult that I've already started the session half an hour ago, and it's difficult to let you know things again from scratch. Okay, you'll miss out the
एक्सक्यूज मी मैम.
okay. Yes.
मैम आई एम क्षितिज पांडे. मैम लिंक ज्वाइन नहीं हो रहा, मैं बहुत देर से ट्राई कर रहा हूँ.
आपका पिंग मुझे अभी आया है. आई हैव ट्राइड लाइक आई वाज
13 पे भी मैंने किया था, उस समय भी नहीं हो रहा था. 313 315 के अप्रोक्स तब से लगा हूँ. 2-3 बार कर चुका हूँ तब से
ओके फाइन.
नहीं हुआ. मैं दूसरे के नंबर से
बट
किए.
हाँ बट ट्राई कि आप कल से 3 ओ सॉरी आप मंडे को 3 PM पे ज्वाइन करो. ठीक है.
मैंने एक्चुअली प्रेजेंटेशन था कॉलेज में, इसलिए मैं यहाँ पे आया था. अभी छूटा था तो टाइम लग गया थोड़ा.
ओके ओके फाइन. ठीक है.
अरे
यस यस म्यूट योरसेल्फ एंड ओके. Yeah. So, yeah. So splits are being created. Okay, and then this your splits are being passed to your different map functions. Okay. Now this processing is being done. Now, what happens is before that, see this will not happen automatically. There will be a request from the client only. Though then a file will be split and the processing will start, right? So what happens is, let's say client has submitted a job. Okay, now this job will go to your job tracker. Okay, now job tracker is one uh, job tracker is basically responsible. It is the resource manager, you can say, for map reduce. Okay, now what this it will do that whatever kind of processing you are doing, okay, whatever kind of job you have submitted, this job tracker is basically responsible for letting each and every map phase map and reduce phase does its job or not. Okay, so job tracker will make sure of that. Okay, so job tracker assigns job to the task tracker. Now these task trackers are basically residing over each map map function. Okay, and your reduce function. Okay, what you can say is that this your job tracker is basically your residing at your master, and task tracker is basically residing at your slave nodes. Okay, or your data nodes. Okay, so master or job tracker will tell the task tracker which is residing on your data nodes that this job has come and you have to uh, do the processing of the data. Then tracks the process of the task tracker. Whatever task tracker is doing, okay, the working of it is being monitored by your job tracker. Then coordinates map and reduce phase. Whatever coordination between the map phase and the reduce phase is required, that is being done by the job tracker. Okay, now the only job for the task tracker is to to basically do the processing of the data. Okay, what a kind of processing you want. Okay, so what was the problem here? Okay, we can see it uh, a smooth sailing kind of scenario. Okay, but the problem was here that already MapReduce is doing the processing work. Okay, MapReduce is already doing the processing work, but along with that it has the thing of resource management as well. Okay, उसे jobs को manage करना है, job को execute करने के लिए you also require some containers, you need some RAM, you need some CPU cores, you need some network bandwidth and everything. Okay, you need some resources to do those things. Okay. So all those resource management and tracking and everything that was being done by the MapReduce also. Okay, तो यहाँ पे processing भी हो रहा है and resource management भी हो रहा है. And because of this and because of this scenario, and also you are not just dealing with the small data, you are dealing with huge amount of data, big data. Okay, so the processing part is also not that easy. Okay, it is time taking and it's a complex one. Okay, you're not just solving a word ground problem, you are doing solving a complex problems as well. Okay, so because of that, the processing and resource management work was turning out to be bur- a burden for MapReduce. Okay, it was eventually hampering the processing capability. Okay, and because of that, because of all this, what we decided was that instead of doing resource management at MapReduce end, we removed this resource management part from MapReduce, and in version 2.0, what we did, we introduced a concept called yarn, and we said that yarn will be solely responsible for your resource management. Okay, and your processing part will be just taken care by the MapReduce. Okay, so here in yarn you have in version 2.0 you had your HDFS, your MapReduce, and your resource manager, or you can say yarn. Okay, so this was the addition in Hadoop version 2.0. Okay, so because of the bulge, or because of this overburdening of job tracker, we basically tried to ease out MapReduce work, and we removed the resource management from the reduce waste. Till Hadoop version 1, the scenario was the same, that MapReduce is responsible for processing as well and resource management as well. Okay, so this is was what the scenario was. So you can see it here, that HDFS, your storage layer, MapReduce for data processing. So the problem was that this designed to run MapReduce jobs only and had issues in scalability, resource utilization, and also we were facing the processing capabilities as well. Okay, scalability issues are the, we were not able to scale the processing power as required. Okay, resource utilization was being hampered. Okay, and overall आपका जो performance है वो down होता है. ठीक है, so for that we introduce yarn. अब yarn हमारे पास एक layer हो गया जो कि solely cluster का resource management कर रहा है. ठीक है, तो storage आपके पास हो गया, resource management manager आपके पास हो गया. Now comes your data processing. So MapReduce we had already. यार्न को इंट्रोड्यूस करने से फायदा क्या हुआ, what benefit we get was that we were able to get other frameworks as well. Okay, now what these other frameworks are, we were able to use Hive, we were able to use Pig, we we were able to use Spark. Okay, so these are the frameworks for doing the different processing. Okay, if we want to do streaming kind of processing, okay, so that we could introduce. Okay, on the base of all these things, the storage is same, Hadoop. Okay, but we were not just limited to the processing capability of MapReduce. Okay, because we know MapReduce is being written in either Java, you can write it in Python or Ruby. Okay, and mostly like 90% or 95% it is times it is written in Java only, because it is built in Java. Okay, so that's why it is mostly written in Java, and Java code is not, it's not a simple Java code, it's an advanced one. Okay, so every data processor, or every, everyone who is who wants to deal with big data, who wants to work on big data, might not be proficient in Java. Okay, so in that case, what we decide, what the solution was, that we can use, somehow we could use other frameworks as well. Okay, so with other frameworks like Hive, you can you do you do your programming in the form of SQL, similar to SQL type of querying we do. For Pig, we have scripting type of. Okay. For Spark, you have the option of Scala. For Spark, you can also do it in Python. Okay. For Spark, you can also do it in Java, and for Spark you can also do it in R. Okay, so based on what kind of proficiency I have in the in a particular language, and also it is like that what kind of work I have been doing throughout. Okay, just because I have the capabilities now and I have MapReduce to work, that doesn't mean that I have to solely learn about Java. It's not possible, it's not practically possible. Okay, the person who is doing 10 or 15 years of job in SQL, now one day he cannot switch to Java for processing. Okay, so that's why we basically introduced Yarn, and with the help of that we were able to use another different frameworks, because all the resource management can be now done through Yarn, and we just changed the processing engine. Okay, so that was the motive behind introducing Yarn, right? So, a brief about Yarn. So, yet another resource negotiator, okay, is a resource manager created by separating the processing engine and the management function of MapReduce. It monitors, manages workload, maintains a multi-tenant environment, manages high availability feature of Hadoop, and implements security control. Okay, so scalability. Now you could scale your cluster based on like you can increase your cluster size. Let's say if you had 10,000 machines, now you could have 1 lakh machines which can concurrently do the task. Then compatibility. That doesn't mean if we have introduced Yarn Hadoop version 1 की सारी चीजें obsolete होती हैं. No, it is it has a better it has as usual compatibility with Hadoop version 1 applications as well. Okay, so that is another uh, pros here. Then resource utilization. Yes, yeah, क्योंकि Yarn solely will be responsible, so a better resource allocation can be done. We can utilize it for improvement of the performance, improvement of the processing speed. So that was there. Multi-tenancy environment can use open source and property data access engines and perform real-time analysis, run ad hoc queries. So this multi-tenancy was also being added when we added Yarn. Okay, so I told you that multiple engines we were able to use. So for interactive queries, we had Days. For column oriented databases handle करने हैं तो आप Apache Base यूज कर सकते हो, Storm यूज कर सकते हो स्ट्रीमिंग डेटा के लिए, ग्राफ डेटाबेसेस थे, we could process those as well. Spark in memory computing के लिए, and there are multiple numerous engines which now can be used for them. The base will be HDFS, and the resource manager will be the this yarn. Okay, and this is along with MapReduce. Okay, so whatever, let's say if I'm using Spark, so for Spark I can use the storage space as HDFS, resource allocation yarn karega, and the processing will be done by the Spark. Okay, so I hope you got the point कि yarn की requirement क्या थी and what benefit we
Yes,
got.
ma'am.
Okay, okay, what changed when we introduced yarn? Okay, now what's the scenario is how resource management now is taking place through yarn. Okay, so what happens is your client basically submits your requests over only on the request of client only things happen. So it has submitted a request. Now you have a resource manager. So see, Hadoop version 1 में आपके पास job tracker था. ठीक है, तो जॉब ट्रैकर जो काम कर रहा था, the work your job tracker was doing, now that work is done by your resource manager. Okay, now resource manager has application manager and scheduler. Now this basically scheduler and application manager are basically working on ki how the resources will be scheduled, what our resources are right now being engaged. Okay, then comes your if and this resource manager is residing on your name node. Okay, on your master, right? Now resource manager, now this node manager is the another entity, and whatever work your task tracker was doing, that work is done by your node manager. Okay, now this node manager is residing on your data nodes. Okay, now each data node has its own node manager. Okay, now what happens is your data is basically at your data nodes. Okay, आपका data nodes में store होता है. Now what will happen? Client ने send किया request that I need to process one particular file. Okay, now this file is stored in your HDFS. That means on your data nodes in the form of blocks. ब्लॉक्स के फॉर्मेट में स्टोर्ड है. ठीक है, सो लेट्स से ये 3 डेटा नोड्स पे आपकी फाइल स्टोर्ड है in the form of blocks. Okay, now what will happen? Client has requested to process this data. Okay, now all the blocks will be processed because client तो as a whole file को process करने के लिए कहेगा. Not client doesn't know that his file is being divided and stored in the blocks. Okay, client just knows that I have stored a file in the HDFS. Okay, now what will happen? This node manager will basically uh, will basically intimate this thing to your node manager. Okay, giving him the information that where this file is basically residing, where the blocks are residing. Okay, so it will give this information, and also it will give the information key you have to process this file. Okay, now once this node manager gets this information, application master gets activated. Okay, once this application master gets activated, it will understand that okay, this file I need to process, what is the mechanism in which I have to process. So basically आपका जो मैप प्रोड्यूस वाला, लेट आई गिव यू एग्जांपल फॉर मैप प्रोड्यूस ओनली. तो जो आपने मैप प्रोड्यूस का प्रोग्राम आपको अप्लाई करना है इस फाइल पे, तो दिस मैप प्रोड्यूस का जो फाइल होगा, आई होप आपको लास्ट क्लास में मैम ने बताया होगा कि हम मैप प्रोड्यूस के लिए जार फाइल क्रिएट करते हैं, राइट? तो दिस जार फाइल बेसिकली विल ट्रैवल टू ईच एंड एवरी नोड. ओके, तो जो मैं आपको कह रही थी मैप प्रोड्यूस में कि यहाँ पे बेसिकली हम एक तरह से डुप्लीकेशन ही कर रहे हैं हमारे मैप लॉजिक का. हम लिखते एक ही उसका डुप्लीकेशन होता है। तो वो डुप्लीकेशन क्या है, वही है जो आपकी ये जो जार फाइल है, दिस इज गोइंग टू योर डेटा नोड्स। ओके, नाउ once application master gets this information, it will ask the node manager that okay, you have given me a job, now I want the containers to perform the job. Okay, now what these containers are: your RAM, your CPU cores, your network, your hard disk. Okay, all these things are being contained, are called as containers. Okay, packages of resources are basically these. Okay, so it will ask for the containers based on the current scenario, based on what kind of resources resource manager is having. It will assign containers to the data nodes. Okay, it will say, it will assign containers to this application master that you have these containers, now perform the job. Okay, now once the containers are received, the execution of these blocks takes place. Okay, now once the file is being executed, okay, and once it is being completed, now the aggregated result will be sent to the client. Once client receives the data, now the application master will give the acknowledgement to your node manager that the job is being completed, and then node manager will tell the resource, intimate the resource manager that the job is being completed, now the containers are free. Okay, then containers are then again released. Basically they will be released from the data nodes, and this intimation will be given to the resource manager. Okay, so a resource manager will update it for at its end that I had provided the containers. Now the job is complete. Now I have received the containers again. Okay, so it will get the updation so that if another request comes, so they can be handled better. Okay, it cannot be like that. We have once we have assigned the containers, they will be fixed. Okay, they will be residing here only, because in that sense we will be wasting the resources. Okay, so that is one thing we do, that once the job is complete, we release the containers. Okay, so this is how the resource manager is basically working. Okay, I hope it is clear. Any queries, anything?
Clear, ma'am.
Okay, fine. Okay, yeah, so this is what yarn is all about and MapReduce is all about. Let's move to the practical session. Okay, so I'll tell you. Okay, 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 so this is your code of for MapReduce. Okay, so here is an example. This code is basically for word count. Okay, so I'll see, show you the file. Okay, it's not this one. Okay, let's say this is my sample file. Okay, I will just increase the font size so that it is much more visible. Okay, so let's say this is the content of my file. Okay, now what I want is that I want the count of the words. Okay, what is the, how many number of occurrence of this is, how many occurrence of is, how many occurrence of the, how many occurrences of example, and likewise. Okay, so what we did was that we wrote a code for your for word count. Okay, since we are counting the words. Okay, now how the structure of word count basic, or how the structure of a map reduce basically works in. Okay, so for a map reduce, see, I'll tell you that the coding part for the MapReduce is, yes, it is difficult. Okay, because you have to you should have an understanding that how many imports you have to do. Okay, now you should also have an understanding that how what class you need to extend and everything. Okay, so yes, it is difficult, but more or less the structure of MapReduce for any kind of a problem remains the same. Okay, you need to have a mapper, you need to have a reducer, and you need to have a driver class. Okay, so basically overall we have to have um, we have to have three things in our uh, three or four things I would say. That one, you should have libraries. Okay, because you need a support of some libraries to basically do the execution. Okay, then the second thing is you need to have a map class. Okay, then you need to have your reduce class, because all the function of mapper and reducer will be defined here. And the third one is you need to have a driver class. Now this driver class is your main class. So if you are aware, जावा में आप जावा में आप जब कोडिंग करते हो तो जो एग्जीक्यूशन स्टार्ट होता है वो मेन क्लास से स्टार्ट होता है, राइट और नो?
Yes, ma'am.
राइट, एम आई
Right.
राइट?
Yes, ma'am.
Yes. So this driver class is your main class. So main class will basically execute will start your execution and will take you again to, first it will take the libraries, then map function and reduce function. And it will also have the basically how your data will be generated, how your output will be generated. Okay, so this is what the flow of your code is. Okay, now let's come to the code again. Yeah, so these are your libraries. So there is an input output exception. So whatever kind of exception you need to handle, that you need to take care of. Then comes your util string tokenization, because since we are doing word count, you need to have tokenization. Okay, आपको tokenization करना ही पड़ेगा, क्योंकि ये फाइल आप ऐसे ही प्रोसेस करके आप वर्ड काउंट नहीं निकाल पाओगे. You have to break this file into tokens word by word and then create the count. Okay, so for that we have string tokenizer. Then there are some you can say variables जिनके basically not variables, I would say data types. Yeah, you need to have some data types which will be handling your data. Okay, now आपने int, हम generally int use करते हैं, long use करते हैं, but this is a new thing, int writable and long writable. So this int writable and long writable are the classes or abstract classes which are basically holding the data. Okay, and basically int writable is somewhat similar to your int. Okay, but here the thing is that we have used this writable is basically an abstract class. Okay, so this we are using. Then we have similar for your long writable for dealing with any kind of text data, on any kind of textual data. We have text, so we have imported all the three. ओके, नाउ व्हाई इंट राइटेबल? इंट राइटेबल इसलिए क्योंकि हम वर्ड काउंट कर रहे हैं, हम 1 2 3 में इनका अकरेंस डिपिक्ट करेंगे. सो फॉर दैट वी हैव इंट राइटेबल. Why long writable? Because we will be initially converting this file into value and the key, the offset value. Initial split यही होगा कि इसका यहाँ से offset value will be the key and this complete line will be the value. फिर इसका key offset value on complete line. ठीक है, तो offset value, since they will be a long they will be a long type of data, so long writable. Then comes your text. Since we are working over textual data, so text. Then your libraries like for mapper, for reducer, configuration file, because you need to configure, do the configurations. Okay, then since map reduce will basically convert your request into a job. Okay, so let's say कि अगर आप ये word count का ही प्रोग्राम है, देखो होता क्या है, आप there is a situation that कि let's say if I've executed this word count program, okay, so it will be taken as a job. Okay, अगर सेकेंड टाइम में लेट्स से आप डेवलपमेंट ही कर रहे हो तो इट इज़ ऑलवेज नॉट पॉसिबल कि आप एक गो में ही आपका कोड 100% रन करे. ठीक है, यू माइट नीड टू बी मेक सम चेंजेस इन दैट. ओके, तो आपके लिए आप एक ही प्रोग्राम को रन कर रहे हो विद सम मॉडिफिकेशंस, बट फॉर मैप रिड्यूस ईच एंड एवरी अटेम्प्ट इज अ जॉब. ठीक है, तो आप इस वर्ड काउंट के प्रोग्राम को आप चाहे एक बार रन करो चाहे 10 बार रन करो, वो हर बार इसको एक सेपरेट जॉब की तरह लेगा. ठीक है, अभी सेपरेट जॉब की तरह क्यों लेगा? बिकॉज दे डोंट, दिस मैप रिड्यूस डजंट नो दैट यू आर executing the word count. It will take it as an independent thing. Okay, so that's why jobs, for that, for dealing with all the kind of that job creation, that is being done by this job library. Then you need to handle your input format, your output format, and also how the file input will be taken, how this file will be, the input file will be taken, and how the output will be generated. Okay, since I told you that you your output will be stored in a file, it will not be shown on your terminal if you are, if you'll be executing. It will be done in the uh, it will be done in the it will be done in the stored in the HDFS. Okay, so so these are the files we have imported. Then last one is the path. So this path library basically deal with that what path you will be giving to your output file. Okay, so when we execute the MapReduce program, no, at that moment only it asks us that what will be the output directory where you want to store your output. Okay, so we provide the output as well, output directory as well, not output not the output file name. We just give the directory,
Storage location.
directory path. Yes, the storage location only. File name will be decided by the Hadoop itself. Okay, so this is what we define, we in this import library. This path will this library will be dealing with that. Now once we imported all these libraries, now what we do is public class word count. Okay, now this is the first, your class is there. Okay, now just hold on for a minute. Okay, yes, so this is your word count class. Okay, and in this word count class, what we have done is we have created the map class. Okay, so this mapper class is basically extending. Sorry, this map class is extends the mapper class. Now this part is important. Okay, now see here we have four parameters: one, two, three, and four. The first two parameters are for your input. Okay, now हमने बात किया था यहाँ पे कि हम इनपुट किस वे में दे रहे हैं, की वैल्यू पेयर में. ओके, नाउ फॉर इनिशियली लेट्स से इफ द फाइल इज दिस, तो इनपुट विल बी फर्स्ट लाइन एंड द ऑफसेट वैल्यू ऑफ दिस लाइन. ठीक है, सो क्योंकि हम ऑफसेट वैल्यू ले रहे हैं, दैट्स व्हाई द फर्स्ट डेटा टाइप वी आर सेइंग इज लॉन्ग राइटेबल. तो दिस इज द की, the first variable is the key, second variable is your text because complete line is coming. Then the next two parameters are for your output, what output this map class will be generating. Okay, so basically input for the map class and output of the map class. ओके, गॉट द पॉइंट. सो इनपुट क्या है मैप प्रोड्यूस में, मैप क्लास में आपका ऑफसेट वैल्यू एज अ की एंड कंप्लीट लाइन एज अ टेक्स्ट. आउटपुट क्या जनरेट करेगा आपका मैप क्लास, टेक्स्ट फॉर्मेट में होगा, क्योंकि नाउ आपका की वैल्यू पे चेंज हो जाएगा. अब क्या की होगा, आपके वर्ड्स, these tokens which we have created. Okay, and the output will be उनका occurrence. Okay, सो लेट्स अंडरस्टैंड दिस फर्दर. तो देखो यहाँ पे लिखा है लॉन्ग राइटेबल की, text will be your value, and context basically defining is that how you'll be basically reading the data. Okay, how this processing will be taken, and is there any exception, then it will throw that exception. Okay, now what we're doing, यहाँ हम जो एक्चुअल लॉजिक है वो हम यहाँ लिख रहे हैं. ओके, नाउ व्हाट वी आर डूइंग इज वी आर सेइंग, वी आर स्ट्रिंग टाइप ऑफ एक लाइन वेरिएबल हमने लिया है एंड वी हैव पास्ड द कंप्लीट वैल्यू टू इट. Okay, now once this line gets the complete value, then what we are doing through the string tokenizer, we are tokenizing the words based on the since we are not defining here कि हम किस बेसिस पे कर रहे हैं. लेट्स से आप लेट्स से अगर यहाँ पे स्पेसेस नहीं होते, ओके, स्पेसेस की जगह लेट्स से कॉमा होता, ठीक है, तो वी वुड हैव डिफाइंड कि हम टोकनाइजेशन जो कर रहे हैं वो कॉमा बेस पे कर रहे हैं, या देयर वुड हैव बीन अ स्पेशल कैरेक्टर लेट्स से स्लैश और एट द रेट और समथिंग. ओके, लेट्स से कोई भी एक डिस्टिंक्ट हमारा वे हो सकता था एक स्प्लिट करने का. सो टोकनाइज कर लिया हमने. सो बाय डिफॉल्ट इट विल टेक द टोकनाइजेशन बेस्ड ऑन द स्पेसेस. सो wherever it will get the space between those, it will consider as one token. Okay, so in this line your tokenization of complete row will happen. नाउ टोकन्स हो गए हैं. नाउ टोकन्स के साथ हमने क्या किया, अब लगाया वाइल लूप एंड वन बाय वन वी रीड द टोकन्स एंड व्हाट वी डिड इज वी assigned value to each token as int writable 1. Okay, so this is here, so this is where your output is generated. Okay, आपने tokens में convert कर दिया है, यानी कि ये फाइल अब कैसे this comma 1, ठीक है, is comma 1, okay, then 2 comma 1. लाइकवाइज वो हर रो को इस फॉर्मेट में कन्वर्ट कर देगा. ओके, नाउ यू सी, आप देखो आउटपुट जो हमने बात करा था टेक्स्ट and int writable. Now your data will be converted in this. Your key is a text and your value is the 1 which we are assigning it. Okay, then yeah, so this job of your map is done. Okay, now comes your result. Okay, now input for the reducer will be text int writable. ठीक है, क्योंकि हमने कहा था कि जो आउटपुट मैपर का होता है वही will be the input for your reducer. Now we were saying that some shuffling and sorting also happens. Okay, now that shuffling and sorting basically happens at the back end. For that you don't need to write any code. Okay, that is being taken care by the functionality only. Okay, so the input will be passed here, and the output for the reducer will be same text and int writable. क्यों? क्योंकि आउटपुट reducer, ये reducer का input हो जाएगा, reducer output कैसा generate करेगा, let's say कि this और उसके total number of occurrence. Okay, so let's say this कितनी बार आ रहा है इस फाइल में, 2 बार. Okay, I could see 2 times. So this will be the final aggregated result. Okay, so this will be the output for your reducer, input, and this is the output. Okay, got the point? So here, that's why we have written int write text and int write table. Okay, now what is the logic behind this? Tokenization हमने कर दिया, तो we have a list of all the keys and their occurrences. Now what we are doing, we need to perform just the aggregation. So we assigned an integer and sum equals to 0. Okay, we have initialized that. Then we are applying a for loop. Okay, so there we are doing what we are doing. We are capturing this. Okay, and what we are doing, based on each key, based on each individual key, we are taking all the values and we are generating the sum of it. Okay, now once the sum is generated, then what we are doing is we are finally defining that for this particular key the summation is this. Okay, so and in the last line we are basically preparing this result. Okay, the final aggregation. Okay, so this is the logic for your reducer. Okay, so first thing is we'll assign some configuration. So in this configuration part, no, it will basically do what this configuration basically does is it basically invokes your resource manager. ठीक है, क्योंकि जैसे ही आप अपना मैप रिड्यूस जॉब को सबमिट करोगे, आप एग्जीक्यूशन स्टार्ट करोगे, द फर्स्ट थिंग विच गेट्स एक्टिवेटेड इज योर रिसोर्स मैनेजर. So through configuration, resource manager gets activated and it will see that okay, a job has come, it will assign a job ID and it will prepare the system for the execution and define all the resources. Okay, resources और containers को वो assign करेगा. ठीक है, so configuration has happened through job. Through this we are basically assigning a job ID to this code, this problem. Okay, then क्योंकि हम जार फाइल्स बनाते हैं, क्योंकि हम जो ये कोड हम जो लिखा है, we will be sending this code in the form of a jar file. Okay, with all the support libraries and everything. Okay, so set jar by class. So what it will do, it will find the jar file with the name of the class. Okay, so आपने देखा होगा यहाँ हमने word count dot class लिखा है and see our class name is also word count. Okay, so we need to make sure that these two are correctly written. Then set mapper class. So this mapper class will define that okay, where is your map class. Then set reducer class. This through this it will identify the reduce class. Okay, then job set output key class. Okay, so how your output key will be taken, how the output value class will be taken, that we have defined. Then set input format, how the input will be taken in, how the output format will be generated, that is being taken. So see here in text input format, text output format, this is basically from here, from these libraries. Okay, So these libraries are well defined. They will be taking care of that how your output will be created. Now, last one is your path, output path. Okay, so you will be giving the output path for how much or where the output of your this execution will be stored. Okay, then file input format and file output format. Okay, how configuring the input output path of the file system into the job. Okay, then finally is the job wait for completion. How, so till your job gets completed, it will wait for the completion and then complete the final execution. Okay, then your output file will be stored at your location once the job is completed. Okay, so this is all what your structure of MapReduce is. Now see, like based on your problem, here we are dealing with MapReduce. Let's say if you're doing some other processing, based on that you can, you know, modify it accordingly. Okay, but more or less what will change is your parameters, okay, and the logic which we are writing here. Okay, and accordingly just few things will be here changing here, or else most of the things are same for any kind of a problem you are doing in MapReduce. Okay, yes, the problem is that yes, this code is quite, you know, um, difficult to understand, and yes, there is a question, always a question, that how you basically how your code will basically get modified if you do another problems and as well. Okay, so this is what the scenario for MapReduce, and this is why what the problem we were facing gradually. Because see here, if you look closely, word count कर रहे हैं हम, a very simplest problem possible that can be. Okay, but see the lines of code. Okay, how many lines of code? Almost 90 lines of code, right? Now imagine, let's, if you're working on a complex problem. Okay, it's not a word count, but it's some complex problem you're doing. Okay, now you can imagine the lines of code that could be. It could go up to 10,000 lines or something. Okay, so that eventually increases the complexity of a code. Okay, and also as complex as your code gets, it always difficult to, you know, debug it. Okay, so that's the problem we were facing with MapReduce as well. Okay, and that's why, and also no one is like, no one, or I would say that a person who is working in Java for at least 10-15 years, only that person will be proficient enough to, you know, design this MapReduce code. Okay, else, like for, if I speak to myself, I am not proficient enough to do this kind of a coding. Okay, so I need an alternative. Okay, so that's why we need to have another solutions. So that's why yarn was introduced. So with yarn हम hive कर सकते हैं through SQL. If I'm good in SQL, I can do that. हमें सिर्फ प्रोसेसिंग से मतलब है. It's not like that we have to have Java in our as a language, proficiency in the language. Okay, we just need to process the data no matter in which language we perform that. Okay, we need to have a clear view that how we'll be processing it, what logic we want, and language doesn't matter. So with that, Spark, your Hive, your Pig, your Storm, and every other processing engines were developed, right? So this is what your MapReduce program is. Now, if I show you the processing. Okay, so let's open the terminal and let me check what files I'm having in the, sorry. Okay, so let's see that what this sample. Okay, I have this word count sample with me. I'll take that and word count underscore sample dot txt. Okay, we have this file with us. Okay. Okay, let's okay. So for word count, what for basically for MapReduce, what we do is we do the coding in Eclipse. Okay, so I'll open this Eclipse first, and okay, okay. So so I suppose this was being discussed that how you'll be doing the execution. Is it? Yes. Okay. So I'll just delete this one so that there is no conflict. Okay, so let's again visit the process basically. So open your Eclipse. Okay, now what we do is go to the file and go to new, and we'll create a Java project. Okay, and let's give the name to this Java project. I would give it as test word count, and let's give another D1 कर देते हैं. Okay, this is the project name. Okay, rest of the things I'll not change, keep it as it is. Then go to your next. We'll keep it as it is. It's basically creating the sources for that. Okay, and finish. Okay, so your Java project is created. Again, right click on this project and go to new, create class. We'll create a class. Okay, you can give package name if you want. If you don't want, don't give it. Okay, we'll just give the class name. I'll give the class name as word count. Okay, and modifies as public. Here we'll be giving public static void main, right? And finish. So your Java class is being created. Okay, now what I'm doing is I'm taking this code. Okay, I hope this code is here in the. I think this code is here. Yes. I'll copy this code and paste it here. Okay, just give me 1 minute. I have to open it with Gedit. Yes, Control All, Control C, and Control V. Okay, so all the files are being stored. All the data is here now. Okay, now what what's the problem with this? See, you have these red marks. Okay, so that means these red marks are not identified um, by code. Okay, so what we need to do is we need to remove and make to import the libraries first. Okay, so what we need to do is, again, go to your code, go to your project, right click, and go to build path. And in build path, what we'll do, we'll configure build path. Okay, now here if you see in the libraries, we do only have GRE1. So what we'll do, we'll add external jars. Okay, now these are the two jars on desktop I'm having: Hadoop Common 2.20 jar and Hadoop MapReduce client core jar. These are the two jar files basically holding all the support libraries which we need. Okay, so I have added them. Now I'll click on all the three and click on OK. So all the referenced libraries are now added. Right, now once I have added all the reference libraries, you see all the red marks are removed. Okay, and if you also see the name of the class here and here are same. Also, here and here the class name should be same. Okay, let's say if I would have given here the class names otherwise. Okay, let's say यहाँ पे कोई और नाम दिया होता तो यहाँ भी मुझे वो चीज़ चेंज करना होता. Okay, because आपका जो jar file है that would be identified with your class name. Okay, so that should match, right? So this is you have this we have done. All the red marks are removed. Okay, so that means it is error free. Now we can create the jar. Okay, see, if you'll create the jar and still there are some red marks, no, your program will not be executed successfully. So make sure that you remove all the red marks and try to understand where the problem is. Okay, it will definitely tell you in the this uh, in the red mark that what the problem is. So try to debug your code accordingly. Okay, so we need to create the jar. Now we'll again go to the project, right click over it, and now we'll go to export. Okay, now here we need to export this code. Okay, this project. Okay, we'll create a jar file. Okay, click on next. Okay, next what we need to export is the text word count D1. Okay, it is already checked in. Now here we'll not be making any changes. The thing is that we can decide the file location. Okay, so I'll browse it and place it on desktop, but I'll give a different name. Let's say okay, wait a minute. Wait a minute. Yeah, so this is the class name now. So here I'll just give it as word count. Okay, this is the jar I have created. Okay, you can browse it and store it on your desired location. So here we just need to give the path. Okay, now click on next. In the packaging we are not doing anything. Again click on next. Now jar manifest specification. Here no need to change anything, just you need to set the main class. Okay, so in the main class, here it is main class. It is not coming properly in my file. I hope here it will come. No, it's not taking. Okay, so whatever, this main class. Okay, so we'll browse the main class and see. This is the main class we are having. Okay, word count and click on OK and go to your finish. Jar export finished with warning. Okay, so it is done successfully. Click on OK, and now come to your desktop. See, word count jar is being created. Okay, now let's see the execution. Okay, so for that I'll open another terminal. Okay, now the method is Hadoop jar location of your input file. Sorry, your uh, your jar file. So the location is home Cloudera desktop slash word count dot jar space enter slash your input file. Okay, so where is your input file? It's in the HDFS, right? And what's the name of it? This is the name. Okay, so word count underscore sample dot txt space enter. Now I'll need to give the directory where I need to store. Okay, so let's give the output directory as big data mr. Okay, for MapReduce. Okay, so this is how you execute your MapReduce code. Okay, we are basically taking the jar file. Now this jar file will be distributed to your data nodes. Okay, and then uh, at the data nodes this file will be searched, the blocks for this file will be searched, and eventually your data will be stored on the directory. Okay, click on enter. Now see, the first thing which is invoked is see your resource manager. ओके देन रिसोर्स मैनेजर के बाद आप देखो सबसे पहले उसने क्या किया है, जॉब रिसोर्स अपलोडर, देन फाइल इनपुट फॉर्मेट उसने देखा है, इनपुट फाइल पाथ देखा है, देन इट इज सेइंग उसने जॉब आईडी क्रिएट किया है. ठीक है, एंड वंस द जॉब आईडी इज क्रिएटेड, आप यहाँ देखो आपका प्रोसेसिंग इनिशियली नाउ योर मैप इज 0, रिड्यूस इज 0. ठीक है, see, your map phase is complete, reduce phase is still not started. Map is done, reduce is done. Okay, both the stages are complete. Then your this job is completed successfully. Then there are some stats. Okay, file system counters, file number in byte, how many bytes written, how many bytes read. Okay, what are the number of operations, कितने HDFS and HDFS में कितना राइट किया, कितना रीड किया. ठीक है, जॉब काउंटर्स. ओके, हाउ आर देयर, मैप रिड्यूस फ्रेमवर्क्स, कितने मैप रिकॉर्ड्स हुए, कितने मैप आउटपुट रिकॉर्ड्स जनरेट हुए, कितने बाइट्स रीड करी गई. ऑल दीज थिंग्स आर डिफाइंड हियर. ठीक है, शफल एरर, वाज देयर एनी एरर इन शफलिंग एंड सॉर्टिंग, फाइल इनपुट फॉर्मेट काउंटर, आपकी फाइल कितने इनपुट की थी, आप देखो यहाँ पे 324 था, आपकी फाइल का साइज देखो यहाँ पे 324. So it is giving you the size of your file which was read. Output file format 339. Okay, so our output which is output file हमारी 339 bytes की है. Okay, so let's check it out. ठीक है, so I'll again come to this, and once we have, okay, I'll go there only. Now, once we have generated the output, okay, now what we need to do is we need to check whether this output directory is created or not. See, if there is a successful execution of your program, na, so your output directory will be created. But if there is an error, your output directory will not be created, and an error will be displayed. Okay, since our execution is successful, let's check that whether the output directory is created or not. So Hadoop fs-ls slash, we'll list the hdfs and see the output directory is created. Yes, it is created. Now I'll see what are the contents in this file. So again, big data underscore mr, enter. See, there are two files here. One is a success file, and the second one is this file. So whatever output your file is holding, that your MapReduce has generated, it is being there in this file. And if you see the output bytes written is 339 here, and similarly here. Okay, so this is your output file. Okay, so we can see the content of it. So how can we see the content of this file? What is the command for that?
Cat command.
Yes, Hadoop hyphen Hadoop fs hyphen cat slash big data underscore mr slash part, sorry, part 5 times 0. Okay, and enter. So this is the output of your file. Okay, this is what we wanted to achieve, is it? Yeah. So this is the output of your file, which is being stored in this on this location. Now see, since this is your single node cluster, तो अगर let's say कि आपके पास multiple node cluster होता, let's say you had a cluster of 4 or 5 machine or so, तो आपका फाइल भी, क्योंकि आप लार्ज फाइल पे वर्क कर रहे होते हैं, तो आपका डेटा नोड्स पे होता स्टोर, ठीक है। तो उस बेसिस पे क्या होता कि हर डेटा नोड के लिए एक अलग फाइल बनता, ठीक है। होता क्या कि आपका फर्स्ट डेटा नोड के लिए ये वाला फाइल होता, सेकेंड डेटा नोड के लिए फाइल क्या होता, पार्ट हाइफन आर 0001, सिमिलरली 002, बिकॉज क्योंकि हम ब्लॉक बाय ब्लॉक उसको स्टोर कर रहे हैं, तो दैट्स वाई द डेटा विल बी स्टोर्ड इन दिस फॉर्मेट। ओके, so this is how your data will be generated and the output will be created in MapReduce. Okay, so this is the complete scenario. So what we'll do is I'll share these files with you. Okay, yeah, and also I think a drive link is yet to be created. So what I'll do is we'll create a drive link, okay, and we'll share with you these files. What you do is you try out executing this, okay. I'll also share the process how you need to execute the this word count, okay, or not a word count, any MapReduce code, okay. So I'll share this word count, and also I'll share another problem with you. And try that you can either you can code it or not, okay. So try it out, that problem. If you face any issue, if you face any issue in execution, do let me know, okay. We'll meet on Monday and we'll see that whether you all are able to do it or not, okay. I would like कि मंडे को आप लोग और ये सारी चीजें एग्जीक्यूट करो, ठीक है। We'll share the files with you for that, okay, so that part you don't need to worry, okay. So I hope MapReduce is clear to you all. Okay, so any queries, or we should conclude the session? Yes, any queries for anyone?
No, ma'am.
Okay, fine. So I'll just take the screenshots of your all presence. Okay, and then we will then you can leave the session. Okay, so give me 2 minutes. I'll just capture your screenshots.